November 3, 1943. Commander Tameichi Hara stood in the intelligence section of the Combined Fleet Headquarters in Truk Lagoon, studying reconnaissance photographs that had arrived from Tokyo less than 6 hours earlier. The images showed a vessel under construction at Newport News Shipbuilding, her flight deck taking shape above a hull that measured 862 feet from bow to stern. His hand trembled slightly as he placed the photograph beside similar images from Bethlehem Steel's Quincy Yard, New York Naval Shipyard, and Philadelphia Naval Shipyard. 4 carriers. 4 identical carriers being built simultaneously using what appeared to be standardized designs and mass production techniques. The implications of what these photographs revealed would haunt Japanese naval planning for the remainder of the war, exposing a miscalculation so fundamental that it called into question every assumption about America's industrial capacity and Japan's ability to sustain carrier warfare across the Pacific. What Hara saw in those grainy images wasn't just ships under construction. It was evidence of an industrial system that treated aircraft carriers not as irreplaceable strategic assets requiring years of careful craftsmanship, but as standardized products that could be manufactured like automobiles on assembly lines operating around the clock. The photographs showed modular hull sections being lifted by massive cranes, prefabricated island superstructures awaiting installation, and flight deck segments that appeared identical across multiple vessels. Each detail suggested production methods that Japanese shipbuilding had never attempted, techniques that prioritized speed and volume over the individual perfection that characterized Japanese naval construction. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Essex-class carrier program had begun in the summer of 1940, nearly 18 months before Pearl Harbor, when American naval planners recognized that the existing Yorktown-class carriers would prove insufficient for sustained Pacific operations. The design that emerged from preliminary conferences at the Bureau of Ships prioritized producibility over individual superiority, creating a vessel that sacrificed some performance characteristics in favor of standardized components that could be manufactured by multiple shipyards simultaneously. Naval architects working on the project studied Henry Kaiser's revolutionary shipbuilding techniques being developed for merchant vessel production, recognizing that similar principles of modular construction and assembly line methods could transform carrier construction from a years-long craftsmanship process into a months-long manufacturing operation. The specifications reflected this production-oriented philosophy. 27,000-ton displacement, length overall of 872 feet, beam of 147 feet at the waterline, 4 steam turbines generating 150,000 shaft horsepower for a top speed of 33 knots. Flight deck measuring 862 feet by 108 feet, capable of operating an air group of 90 to 100 aircraft. Armor belt of 2.5 to 4 inches protecting machinery spaces and magazines. Most critically, the design incorporated modular construction techniques that allowed hull sections, machinery spaces, and superstructure elements to be fabricated separately in different facilities and assembled during final construction phases. Components could be manufactured inland and transported by rail to coastal shipyards, distributing the production load across America's vast industrial infrastructure. Japanese naval architecture had followed a different path entirely. The Shokaku and Zuikaku, completed in 1941, represented the pinnacle of Japanese carrier design. These vessels displaced 32,000 tons and could launch larger air groups than their American counterparts, with enclosed hangar decks that provided better protection for embarked aircraft. Their machinery plants generated 160,000 shaft horsepower, giving them top speeds of 34 knots that matched the Essex class. The armament included 16 5-inch dual-purpose guns, compared to 12 on early Essex-class vessels. By most individual performance metrics, the Shokaku-class carriers equaled or exceeded American designs, but they required specialized construction techniques and lengthy building times that made rapid production impossible. Each carrier emerged as a unique creation, with components custom-fitted during construction processes that stretched for 3 years, from keel laying to commissioning. The Shokaku's keel had been laid in December 1937, and the vessel hadn't, commissioned until August 1941, nearly 45 months later. Zuikaku required similar timeframes. Japanese shipyards lacked the production capacity to build multiple fleet carriers simultaneously, as the specialized facilities, skilled workers, and custom-fitting processes required for each vessel prevented parallel construction programs. The result was carriers that performed slightly better as individual vessels, but could never be produced in quantities sufficient to match American output once Essex-class production reached full capacity. The photographs that Hara examined told a story of American shipbuilding capacity that Japanese planners had dismissed as impossible throughout the war's planning phases. Newport News had laid the keel for USS Essex on April 28, 1941. The vessel slid down the ways exactly 15 months later, on July 31, 1942, her hull complete and superstructure taking shape. She commissioned as a fully operational warship on December 31, 1942, just 8 months after launch, and 20 months total from keel laying to combat readiness. The Essex had conducted her shakedown cruise in Chesapeake Bay during January 1943, worked up her air group through February and March, and arrived in the Pacific Theater by May, less than 17 months after her launch. 20 months from start to finish for a complex warship that Japanese yards required 40 to 45 months to complete, assuming uninterrupted access to materials and skilled workers. But the construction timeline for individual ships represented only part of the intelligence picture that troubled Hara as he compiled his analysis. The reconnaissance photographs showed multiple Essex-class carriers under construction simultaneously at yards scattered across the American East Coast: USS Yorktown building at Newport News, USS Intrepid at Newport News, USS Hornet at Newport News, USS Lexington at Bethlehem Steel Quincy, USS Bunker Hill at Bethlehem Steel Quincy, USS Wasp at Bethlehem Steel Quincy, USS Hancock at Bethlehem Steel Fall River, USS Bennington at New York Naval Shipyard, USS Boxer at Newport News. The list continued through 9 separate vessels in various stages of completion, from newly laid keels to ships approaching launch dates. And intelligence reports suggested this represented only the first wave of Essex-class construction, with additional vessels planned for laying down as soon as building ways became available from earlier launches. Commander Hara had served as executive officer aboard the carrier Zuikaku during the Pearl Harbor operation and the subsequent battles in the Coral Sea and at Midway. He understood carrier warfare from the perspective of someone who had witnessed Japan's early victories when superior training and aggressive tactics had compensated for numerical parity with American forces. He had watched Japanese carrier aviation dominate the opening phases of the Pacific War, striking targets from Pearl Harbor to Ceylon with devastating effectiveness. But he had also witnessed the Battle of Midway in June 1942, where Japanese carrier power had been broken in a single day's fighting that cost Japan 4 irreplaceable fleet carriers, while American forces lost only the Yorktown. The loss of Akagi, Kaga, Soryu, and Hiryu had represented not just ships, but the core of Japan's experienced carrier air groups, pilots and maintenance crews whose training and expertise could not be replaced even if new carriers could be built. The intelligence photographs before him represented a threat more fundamental than improved American tactics or better aircraft. They revealed an enemy who had solved the industrial problem of carrier production, transforming these complex vessels from scarce strategic resources into manufactured products that could be built faster than they could be sunk. The modular construction, visible in the photographs, showed hull sections being assembled from prefabricated components with standardized dimensions that allowed interchangeable parts manufactured at different facilities. Flight deck segments appeared identical across multiple vessels, suggesting mass production of deck plating, catapult systems, and arresting gear. Even the island superstructures seemed to follow common designs that would allow prefabrication at specialized facilities before transport to final assembly sites. The strategic implications became clearer as Hara compiled data from multiple intelligence sources throughout November and December 1943. American shipyards had launched 3 Essex-class carriers in 1942, Essex herself in July, Lexington in September, and Yorktown in January 1943. Intelligence projections based on construction timelines visible in reconnaissance photographs suggested at least 6 more would commission during 1943, with additional vessels following at accelerating rates as shipyards refined production techniques and resolved bottlenecks. Japan's entire carrier construction program planned for 2 new fleet carriers by the end of 1943, the Taiho and the Unryu, vessels that would require extended shakedown periods before achieving operational readiness. Even when commissioned, these carriers would operate with air groups depleted by losses and trained by instructors whose own combat experience had been lost at Midway and subsequent battles. The numbers told a story of diverging trajectories that no amount of tactical skill could overcome. American carrier strength would increase steadily throughout the war, adding vessels at rates approaching 1 per month during peak production periods. Japanese losses could not be replaced at rates sufficient to maintain force parity, let alone achieve the numerical superiority necessary for offensive operations. The Battle of Midway had cost Japan 4 fleet carriers in a single day: Akagi, Kaga, Soryu, and Hiryu, representing over 40% of Japan's total carrier strength at the time. American yards would replace equivalent losses within 4 to 6 months through Essex-class production that treated carrier construction as a standardized industrial process rather than custom shipbuilding requiring years of specialized craftsmanship. Hara's analysis extended beyond simple vessel counts to the broader implications for carrier air groups and pilot training programs. Each Essex-class carrier embarked an air group of 90 to 100 aircraft, including 36 Grumman F-6F Hellcat fighters, 36 Douglas SBD Dauntless dive bombers, and 18 Grumman TBF Avenger torpedo bombers. American aircraft production exceeded Japanese output by ratios approaching 3 to 1 in 1943, with monthly production figures that allowed continuous replacement of combat losses while expanding total air group strength. Fighter production alone reached over 1,000 units per month by late 1943, ensuring adequate supplies for both carrier air groups and land-based squadrons supporting Pacific operations. More critically, pilot training programs graduated aviators faster than combat operations consumed them, creating a sustainable pipeline that allowed American carrier aviation to improve continuously throughout the war. Navy flight schools expanded from producing hundreds of pilots annually before the war to graduating thousands by 1943, with training programs that provided extensive instrument instruction, gunnery practice, and tactical exercises before assignment to combat units. New pilots arrived at fleet carriers with 300 to 400 hours of flight time, including 50 to 100 hours in the specific aircraft types they would fly in combat. This comprehensive training produced aviators who could be integrated into experienced air groups without degrading overall unit effectiveness. Japan's training infrastructure, by contrast, had been overwhelmed by losses at Midway and subsequent engagements. The Battle of Midway alone had cost Japan over 100 experienced carrier pilots, including air group commanders and squadron leaders, whose tactical expertise represented years of training and combat experience that could not be rapidly replaced. The survivors of Midway found themselves training replacement pilots using compressed curricula that shortened instruction periods and reduced flight hour requirements to rush graduates into combat units that desperately needed replacements. Fuel shortages further compromised training effectiveness, as aviation gasoline allocations forced reductions in flight training hours that left new pilots inadequately prepared for the demands of carrier operations and combat flying. The result was a steady decline in average pilot quality that no amount of individual skill among surviving veterans could offset. Japanese carrier air groups in late 1943 contained mixtures of highly experienced pilots who had survived multiple combat deployments and inexperienced replacements with minimal training, creating units whose overall effectiveness fell well below the standards of early war Japanese naval aviation. American air groups, by contrast, maintained more consistent quality levels as continuous rotation of pilots between combat deployments and training assignments distributed experience throughout the force, while providing veterans opportunities to pass tactical knowledge to newer pilots through formal instruction programs. The photographs also revealed details about American construction techniques that distinguished Essex-class production from Japanese shipbuilding practices that Hara had observed during his service. The modular hull sections, visible in images from Philadelphia Naval Shipyard, showed evidence of welding, rather than riveting, a faster joining method that also produced lighter structures for equivalent strength. Japanese naval construction still relied heavily on riveted joints that required skilled workers and time-consuming fitting procedures. Welding allowed faster assembly of prefabricated components, while using less skilled workers who could be trained in weeks rather than years, enabling rapid expansion of shipyard workforces to meet wartime production demands. The flight decks appeared to use standardized dimensions and layouts across all Essex-class vessels under construction. Hara could see that catapult positions, arresting wire spacing, and deck edge elevator configurations remained consistent from ship to ship, suggesting that components could be manufactured at specialized facilities and transported to final assembly sites rather than custom-built for each vessel. This standardization offered enormous advantages in operational support, as spare parts, maintenance, procedures, and repair techniques remained consistent across the entire class. Japanese carriers incorporated significant variations even within the same class, as designers implemented modifications based on operational experience or incorporated improvements that became available during lengthy construction periods. Even the island superstructures seemed to follow common designs that would allow prefabrication rather than custom construction for each vessel. Hara noted that the bridge arrangements, funnel uptakes, and radar mast positions, visible in photographs of different ships, showed remarkable similarity, suggesting that entire island assemblies might be fabricated at one facility and transported for installation during final construction phases. This approach would eliminate weeks or months from construction schedules, while ensuring consistent layouts that simplified crew training and operational procedures. Japanese carriers incorporated more sophisticated features in some respects that reflected different design priorities. The Shokaku-class vessels had enclosed hangar decks that provided better protection for embarked aircraft compared to the Essex-class open hangar design. Their armor schemes emphasized protection of machinery spaces and magazines at the expense of flight deck armoring, while Essex-class vessels distributed armor more evenly throughout the hull structure. The Japanese ships had better compartmentalization that theoretically improved damage control capabilities. But these marginal advantages in individual ship performance meant nothing when America could produce 3 or 4 carriers in the time Japan required to build one. Industrial warfare favored mass production over individual superiority, quantity over quality, when the performance differences remained relatively modest rather than decisive. The intelligence briefing that Hara prepared for Admiral Minechi Koga, commander of the combined fleet, laid out these findings with careful attention to verified facts rather than speculation or wishful interpretation. American shipyards had launched USS Essex, USS Yorktown, and USS Lexington during 1942. USS Intrepid and USS Hornet had launched in April and August 1943, respectively. USS Bunker Hill would commission within weeks, followed by USS Wasp, USS Hancock, and additional vessels throughout early 1944. 6 more Essex-class carriers were under construction at various facilities with launch dates scheduled throughout 1944 and into 1945. Intelligence analysts, studying construction photographs and naval contractor reports, estimated total Essex-class production would reach at least 16 vessels by the end of 1945, with potential for additional units if the war continued beyond that time frame. The program showed no signs of slowing or encountering resource constraints that might limit production rates. American steel production exceeded 100 million tons annually by 1943, providing adequate materials for simultaneous construction of carriers, battleships, cruisers, destroyers, submarines, and merchant vessels without compromising civilian industrial needs. Shipyard capacity had expanded dramatically through construction of new facilities and modernization of existing yards, with improved equipment and production techniques borrowed from automotive manufacturing. The workforce had grown from pre-war levels of several 100,000 to over 2 million by late 1943, including large numbers of women workers who had entered shipbuilding trades to replace men serving in combat units. Koga received the briefing in his quarters aboard the battleship Musashi on December 8, 1943, listening with the controlled expression of an officer accustomed to receiving bad news without visible reaction. The Admiral had inherited command of the combined fleet following Yamamoto's death in April 1943, when American fighters had intercepted and shot down his transport aircraft over Bougainville. Koga assumed leadership of naval forces that were already beginning to feel the material strain of prolonged warfare against opponents whose industrial capacity exceeded Japanese production by widening margins with each passing month. The Admiral understood that Japan's strategic position depended on achieving decisive victories that would force America to negotiate rather than continuing the attritional warfare that favored the side with superior industrial capacity and unlimited replacement capability. The Essex-class production program eliminated any realistic prospect of such decisive victories in the carrier warfare that had dominated Pacific naval operations since Pearl Harbor. Even if Japanese forces managed to sink multiple American carriers in a single engagement through superior tactics or fortunate circumstances, replacement vessels would arrive within months, while Japan's losses remained permanent. The combined fleet had begun the war with 6 large fleet carriers, Akagi, Kaga, Soryu, Hiryu, Shokaku, and Zuikaku, plus 4 smaller carriers, Ryujo, Hosho, Zuiho, and Shoho. Midway had reduced the fleet carrier count to 2, Shokaku and Zuikaku, which remained operational. The light carrier Ryujo had been sunk during the Battle of the Eastern Solomons in August 1942. Shoho had been destroyed during the Battle of the Coral Sea in May 1942. New construction would add perhaps 3 more fleet carriers by late 1944, Taiho, Unryu, and possibly Amagi, if construction proceeded without delay. This would bring total operational strength to 5 fleet carriers, plus surviving light carriers, facing an American force that would number 15 to 20 Essex-class vessels, plus surviving pre-war carriers like Enterprise and Saratoga, plus numerous light carriers, converted from cruiser hulls, plus escort carriers supporting amphibious operations. The numerical disparity approached 4 or 5 to 1 in America's favor, making traditional fleet engagements suicidal for Japanese forces that could expect to be overwhelmed by sheer numbers regardless of tactical skill or individual pilot quality. The strategic math became inescapable once these production rates were acknowledged and their implications accepted. Japan could not win a carrier war against opponents who built carriers faster than they could be destroyed in combat. Every engagement became a losing proposition regardless of tactical outcomes, because American losses were temporary setbacks that would be remedied within months through replacement vessels rolling off production lines, while Japanese losses were permanent reductions in combat power that could not be replaced at rates sufficient to maintain force levels. The doctrine that had guided Japanese carrier operations since Pearl Harbor, achieving decisive victories through superior training and aggressive tactics that exploited temporary numerical parity or slight advantages, had become obsolete once the industrial disparity reached levels that made attrition warfare inevitable. Hara's analysis included details about specific Essex-class vessels that revealed the standardization underlying American production methods and the systematic approach that enabled rapid construction. USS Essex and USS Yorktown had been built simultaneously at Newport News Shipbuilding, with their construction proceeding on parallel building ways that shared tooling, fabrication facilities, and workforce training programs. The vessels launched just 3 months apart, Essex in July 1942 and Yorktown in January 1943, and commissioned within weeks of each other, demonstrating that American yards could maintain multiple carrier production lines without compromising construction timelines or quality standards. The parallel construction actually improved efficiency, as workers applied lessons learned on one vessel to the other, while shared tooling and fixtures reduced setup times and improved dimensional accuracy. The modular construction approach extended to the vessel's machinery, plants, and electrical systems in ways that Japanese naval architects had never attempted. Intelligence analysts studying the photographs and technical documents captured from damaged American vessels noted that generator configurations and boiler arrangements appeared identical across multiple Essex-class ships. The main machinery consisted of 4 sets of geared turbines driving 4 propeller shafts, with each turbine receiving steam from 2 boilers operating at 600 pounds per square inch pressure. This standardized power plant configuration meant that components could be manufactured to common specifications rather than custom-fitted during construction, dramatically reducing the skilled, labor requirements and construction time needed for machinery installation. Electrical systems followed similar standardization principles. Essex-class carriers used common voltage standards, switchboard configurations, and distribution networks that allowed interchangeable components across the entire class. Spare parts could be transferred between vessels without modification, and electricians trained on one Essex-class carrier could work on any other vessel in the class without additional instruction. This standardization offered enormous advantages in operational support that extended beyond simple maintenance to encompass battle damage, repair, and wartime modifications. When USS Franklin survived devastating kamikaze damage in March 1945, repair crews used components salvaged from other vessels under construction to restore her electrical systems, work that would have been impossible if each carrier incorporated unique electrical configurations. Japanese carrier. Construction had never achieved such standardization despite multiple vessels being built to common design classes. The Akagi and Kaga, converted from battleship and battlecruiser hulls during the 1920s, bore little resemblance to purpose-built carriers like Shokaku and Zuikaku. But even vessels of the same class incorporated significant variations as designers, implemented improvements and modifications based on operational experience gathered during sea trials and early deployments. The Shokaku and Zuikaku, though nominally sister ships, differed in numerous details of equipment arrangement, armor distribution, and system configurations that had evolved during their overlapping construction periods. The lack of standardization complicated logistics and maintenance, while ensuring that construction techniques and lessons learned on one vessel provided limited benefits when applied to subsequent ships. The Essex-class program demonstrated that American naval architects had learned lessons from commercial shipbuilding that Japanese designers had never applied to carrier construction or had rejected as unsuitable for warship production. Henry Kaiser's revolutionary Liberty ship program, launching merchant vessels in weeks rather than months through assembly line techniques borrowed from automotive manufacturing, had influenced how American planners approached carrier production. While carriers remained far more complex than cargo ships with their elaborate flight deck systems, aircraft handling equipment, and sophisticated radar and communications installations, the same principles of standardized designs, modular construction, and parallel production applied once. Naval architects accepted that some performance compromises were acceptable in exchange for dramatically increased output. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Koga's strategic planning staff attempted to develop countermeasures that might offset American numerical superiority through tactical excellence or technological advantages during strategy sessions held throughout December 1943 and January 1944. The proposal that emerged focused on developing longer-range carrier aircraft that could strike American task forces before enemy planes reached Japanese carriers, exploiting the superior range of Japanese torpedo bombers and the climbing capabilities of Zero fighters to achieve favorable engagement conditions. The concept assumed that if Japanese pilots could strike first and disengage before American counterstrikes arrived, superior aircraft performance and better-trained pilots could achieve favorable exchange ratios that would erode American carrier strength faster than Essex-class production could replace losses. The analysis underlying this strategy ignored fundamental realities about industrial warfare that Hara's intelligence work had made apparent to anyone willing to acknowledge them. Even if Japanese pilots achieved 2-to-1 kill ratios against American aviators, which seemed increasingly unlikely given deteriorating Japanese training standards and steadily improving American aircraft like the F-6F Hellcat that matched or exceeded zero performance, the exchange would still favor America in any sustained campaign. Japanese pilot losses could not be replaced at rates sufficient to maintain operational capability, as experienced aviators were killed or wounded, and training programs struggled to produce adequate replacements. American training programs graduated enough aviators to sustain operations while continuously improving average skill levels through selection of the most capable graduates for carrier assignments and rotation of combat veterans through instructor positions that distributed tactical knowledge throughout the training pipeline. Moreover, the assumption that Japanese forces could choose engagement conditions favorable to their tactical doctrines ignored the operational realities of carrier warfare in 1944. American carrier task forces operated with such overwhelming strength that they could afford to absorb losses while maintaining offensive momentum through immediate reinforcement from reserve vessels and replacement aircraft. Japanese forces lacked the numbers to achieve the concentrated superiority needed for decisive victories at acceptable cost, while American submarines and aircraft interdicted supply lines that made it impossible to maintain carrier readiness even when vessels remained physically intact. The ability to deliver first strikes meant nothing if subsequent American counterstrikes destroyed Japanese carriers faster than their air groups could land, refuel, and launch follow-up attacks. The photographs from American shipyards continued arriving at Combined Fleet headquarters throughout late 1943 into 1944, each batch revealing additional Essex-class vessels under construction or entering service with depressing regularity. USS Bunker Hill commissioned in May 1943, USS Wasp in November 1943, USS Hornet in November 1943, USS Hancock in April 1944, USS Ticonderoga in May 1944, USS Randolph in October 1944. The launch dates came with mechanical regularity that suggested assembly line production schedules rather than traditional shipbuilding timelines, where each vessel's completion depended on resolution of unique construction challenges and availability of specialized components. Intelligence reports tracking Essex-class construction identified patterns that revealed the systematic nature of American carrier production. Vessels laid down at Newport News typically commissioned 20 to 22 months later. Bethlehem Steel Quincy completed carriers in similar timeframes. New York Naval Shipyard required slightly longer periods, 24 to 26 months, reflecting that facility's focus on more complex construction projects and modifications of existing ships alongside new construction. But even the slower yards maintained consistent schedules that allowed accurate prediction of when new carriers would join the fleet, demonstrating that American shipbuilding had achieved industrial repeatability that Japanese yards never approached. By mid-1944, American carrier strength in the Pacific had reached levels that made Japanese defensive operations nearly impossible to sustain without accepting catastrophic losses. Task Force 58, the fast carrier task force of the Fifth Fleet under Admiral Raymond Spruance, deployed 9 Essex-class carriers, plus 4 light carriers, converted from cruiser hulls during operations, supporting the Marianas Campaign. This single formation embarked more aircraft than Japan's entire Consensus remaining carrier aviation force, while the vessels themselves incorporated damage control features and armor protection that made them far more survivable than their Japanese counterparts when subjected to air attack or submarine torpedo hits. The Battle of the Philippine Sea in June 1944 would demonstrate the consequences of the industrial disparity that Hara had identified in his intelligence analysis, compiled 6 months earlier. American carrier forces built around Essex-class vessels launched over 400 aircraft in coordinated strikes against Japanese formations approaching the Marianas, while Japanese carriers struggled to launch effective counterattacks with air groups that had been depleted by losses during previous operations and inadequate replacement pipelines that couldn't keep pace with combat attrition. The engagement that American pilots would call the Great Marianas Turkey Shoot saw Japanese naval aviation effectively destroyed as an offensive force, with losses exceeding 400 aircraft and 3 carriers sunk, while American losses totaled fewer than 30 aircraft and no ships lost to enemy action. The battle unfolded exactly as Hara's analysis had predicted. Japanese forces attempted to exploit their longer aircraft range by striking American task forces from distances that should have prevented immediate counterattacks. But American radar detected the incoming raids while they were still over 100 miles distant, allowing fighters to intercept Japanese formations before they reached the carriers. The F-6F Hellcats that met Japanese attackers enjoyed performance advantages in speed and diving ability that offset any remaining Japanese advantages in maneuverability, while American pilots benefited from superior training and combat experience that had been continuously accumulated and distributed throughout carrier air groups. The Japanese strikes that penetrated American fighter screens encountered defensive anti-aircraft fire coordinated by radar directors that tracked incoming aircraft and directed gun batteries with unprecedented accuracy. Essex-class carriers mounted 12 5-inch dual-purpose guns in single mounts distributed around the flight deck edges, supplemented by dozens of 40mm Bofors guns and 20mm Oerlikon cannon that created walls of fire through which Japanese aircraft had to fly to reach torpedo dropping or bomb release positions. The combination of fighter interception and anti-aircraft fire reduced Japanese strike effectiveness to negligible levels, with most attackers shot down before reaching attack positions and survivors facing such heavy fire that accurate weapon delivery became nearly impossible. American counterstrikes launched against Japanese carriers demonstrated the advantages of overwhelming numerical superiority combined with systematic coordination. Task Force 58 could launch strikes of over 200 aircraft from multiple carriers, creating attack formations so large that Japanese defenses became saturated, regardless of individual fighter pilot skill or anti-aircraft gun accuracy. The concentrated attacks overwhelmed Japanese carriers through sheer weight of numbers, delivering torpedo and bomb hits that no amount of damage control capability could overcome. The carrier Taiho, Japan's newest and most heavily armored carrier, sank from a single submarine torpedo hit that triggered gasoline vapor explosions when damage control teams mishandled ventilation procedures. The carrier Shokaku absorbed multiple torpedo hits that opened her hull to progressive flooding that eventually capsized the vessel despite desperate damage control efforts. The carrier Hio succumbed to torpedo damage that disabled her machinery and left her dead in the water for American submarines to finish off. Commander Hara survived the war and wrote extensively about his experiences during the decades following Japan's surrender, including detailed accounts of the intelligence work that revealed American carrier production capabilities and the strategic implications that Japanese command authorities refused to fully acknowledge. His post-war writings emphasized that Japan's defeat in carrier warfare was determined not by tactical failures, insufficient courage, or lack of fighting spirit among Japanese naval personnel, but by fundamental disparities in industrial capacity that made sustained operations impossible once American production reached full mobilization. The Essex-class program represented systematic American advantages in manufacturing capability, resource availability, and industrial organization that Japanese military culture had failed to anticipate during pre-war planning or counter effectively once war began. The vessels themselves proved remarkably successful in service beyond simply overwhelming Japanese forces through numerical superiority. Essex-class carriers participated in every major Pacific operation from Tarawa in November 1943 through the final strikes against the Japanese home islands in August 1945, demonstrating operational flexibility and combat effectiveness that validated the design compromises made to enable rapid production. Several vessels survived kamikaze hits that would have sunk earlier carriers, demonstrating that the standardized design incorporated substantial survivability features despite being optimized for rapid production rather than maximum individual performance. USS Franklin absorbed 2 bomb hits from a Japanese aircraft in March 1945 that killed over 700 crew members and left the ship burning and listing heavily, yet damage control teams saved the vessel, and she steamed to Brooklyn under her own power for repairs. USS Bunker Hill survived 2 kamikaze hits in May 1945 that killed nearly 400 sailors, but remained afloat and operationally capable after damage control procedures that demonstrated the robustness of Essex-class construction. Post-war, many Essex-class carriers remained in service through the 1970s and beyond, receiving modifications that allowed them to operate jet aircraft and serve in roles never imagined when their keels were laid during the early 1940s. Several underwent extensive reconstructions during the 1950s that modernized their flight decks, updated their electronics and radar systems, and reinforced their structures to handle heavier aircraft. USS Lexington served as a training carrier until 1991, over 48 years after her original commissioning, testament to the fundamental soundness of designs that had prioritized functionality and producibility over cutting-edge performance. The standardized construction that had enabled rapid wartime production also facilitated peacetime modifications and upgrades. As consistent, configurations allowed uniform improvements across multiple vessels without requiring custom engineering for each ship. The strategic lessons from Essex-class production extended beyond World War II naval operations to influence how military forces approached weapons procurement and industrial mobilization throughout the Cold War era and beyond. The program demonstrated that modern warfare favored nations that could mobilize industrial capacity rapidly and sustain production of complex weapons systems through standardized designs and mass manufacturing techniques. Individual weapons superiority mattered far less than the ability to produce adequate weapons in overwhelming quantities, a truth that applied not just to carriers but to tanks, aircraft, ships, artillery, and eventually nuclear weapons during the decades of superpower competition that followed World War II. Japanese naval planners in 1941 had counted American carriers visible at Pearl Harbor and in Atlantic deployments, cataloguing 8 vessels that represented America's entire fleet carrier strength at the time. They calculated that eliminating this finite force through the Pearl Harbor strike and subsequent decisive fleet engagements would secure Japanese dominance in the Pacific for years or decades, providing time to consolidate territorial gains and establish defensive perimeters that American forces would find too costly to breach. The calculations failed to understand that the carriers they could count represented only a fraction of American shipbuilding capacity that would be mobilized once warfare began. The 8 carriers visible in 1941 multiplied into dozens by 1945, with Essex-class vessels forming the backbone of a carrier force that achieved complete dominance over Pacific waters. The Essex-class program transformed carrier aviation from a specialized capability possessed by a few nations into an industrial product that America could manufacture faster than any enemy could destroy the vessels, proving that wars are won by those who build systems rather than those who build individual weapons. The 24 Essex-class carriers that entered service during World War II represented not just ships, but a revolution in how nations approached military production, applying industrial engineering principles and mass manufacturing techniques to weapon systems that had previously been treated as custom creations, requiring years of specialized craftsmanship. The success of the program validated approaches to military procurement that emphasized producibility, standardization, and rapid deployment over pursuit of maximum individual performance, lessons that would influence American military planning throughout the Cold War and into the 21st century. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.